Dear students, welcome to Easy BTech, your guide for BTech and beyond. So we are discussing subject signals and systems. Today's topic is Fourier series. Still we are going to discuss problems on Fourier series because they are very important for examination. And before going to discuss our problems, please share the channel. It is very helpful to you. Let's see the today's session, Fourier series. So the problem is determine trigonometric Fourier series for the given periodic signal. So this is the periodic signal given. We are going to see trigonometric Fourier series for the given periodic signal. And so on. It will repeat up to infinity. Similarly, left side also the same signal is going to repeat. Okay. So here this is 0. This is 0. Here pi. This is 2 pi. 3 pi. Minus pi, minus 2 pi, and amplitude of this signal is A. This is A. The given signal is denoting as x of t. So this is the signal. For this signal we have to find out trigonometric Fourier series. Find trigonometric Fourier series. Let's do it. First of all, trigonometric or exponential Fourier series, we need to identify the time period, fundamental time period. So what is the fundamental time period? So 0 to 2 pi, right? This is the fundamental time period. So t is equal to 2 pi. After time period, omega naught, fundamental frequency, which is equal to 2 pi by t. So 2 pi divided by 2 pi, it is 1. After that, we should write x of t expression. So if you observe x of t, 0 to 2 pi, x of t for one cycle, for one complete cycle. So we have line 0 to pi, we have line, and pi to 2 pi, we have x of t 0. So that is a clarity by observing x of t. So line equation 0 to pi. So this line is passing through origin. So what is the line equation? Y equal to mx. Y is equal to mx. This is the line equation. So here x means x-axis. So in the place of xt, y means y-axis in the place of y, x of t. So what about slope? So do the slope here. So this point is 0, 0, and this point is, what is this point? Pi, a. Generally point is x, y. First x coordinate, then y coordinate. X is pi, y is a. So now slope m, y2 minus y1, a minus 0 by x2 minus x1, pi minus 0. So a by pi. So this is the x of t, at by pi. Where to where it is? 0 to pi. And what about pi to 2 pi? X of t is 0. So pi to 2 pi. Pi to 2 pi. So this is the clarity about x of t. Let's start trigonometric Fourier series. First we'll write the definition of trigonometric Fourier series. So what is the definition? A naught plus summation n is equal to 1 to infinite a n cos n omega naught t plus bn sin n omega naught t, sin n omega naught t. So this is the trigonometric Fourier series definition. Let's do a naught. A naught is the average value or DC value of x of t. The formula 1 by t integral 0 to t x of t dt. 1 by t integral 0 to t x of t dt. So here x of t is at by pi. Only it is 0 to pi. But t, capital T time period is 2 pi. So this integral 0 to 2 pi and x of t is available only 0 to pi, which is at by pi. Pi to 2 pi it is 0. That is why what we can do, 1 by 2 pi integral 0 to pi, what is x of t? At by pi dt. And what about pi to 2 pi? Pi to 2 pi, here x of t is 0, so no need to do it, not necessary. So now we can do this integration, we get a naught. Now a naught is equal to, here a by 2 pi square, and integration of t square by 2, and limits is from 0 to pi. Just substitute upper and lower limits, we have a naught. So 2 pi square, here pi square minus 0. After substituting upper limit pi square, lower limit is 0, and by 2, the by 2 we can take. So here pi square get cancelled. Now the remaining is the a naught. What is remaining? A by how much? 4. This is the a naught. Right? A by 2 into 2, 4. This is the DC value of given signal. Let's go to AN. Go to AN. So formula for AN, what is the formula? 2 by t integral 0 to t x of t cos n omega naught t dt. Cos n omega naught t dt. So I told you already, here t is 2 pi, integration is 0 to 2 pi, but 0 to 2 pi, our x of t is available only from 0 to pi. Pi to 2 pi, x of t will be 0. That's what. So the integral limits 0 to pi only. At by pi, x of t is at by pi into cos n, what is omega naught? Omega naught is 1, so dt. Now we can do simplification. Here 2 get cancelled. A we can write outside. So an is equal to a, capital A by pi into pi square, pi into pi square. Here uv, integral uv. So what is integral uv? That I am following. U is t, integration of cos sin nt by n minus u dash, t derivative is 1, cos integration is sin, again sin integration minus cos. So it will become plus cos nt by n square, cos nt by n square. This is cos nt by n square. Now n square. Limits are from 0 to pi. Limits are 0 to pi. So go for substitution of limits, upper and lower limits. So first we substitute upper limit. A by pi square. The upper limit is t sin n pi divided by n plus cos n pi by n square. This is the upper limit. Minus lower limit is 0. So 0 into sin 0 is 0. Right? 0 and plus cos 0 is 1. So 1 by n square. This is the lower limit. Close the bracket. So here t is pi, right? Upper limit is pi. So here pi we have. This is pi. In the place of t, it is pi. Limit we need to take. Upper limit. So now see the value sin n pi. What is sin n pi? 0. So 0 into pi is 0. Cos n pi. What is the cos n pi value? minus 1 power n, that is cos n pi. Let's take that values. So an is equal to a by pi square minus 1 power n divided by n square, and here minus 1 by n square. So we can take n square common. So a by pi square n square minus 1 power n minus 1. So here I am discussing cases when n is even, when n is odd. So if you take n value even, what happens? Like 2, 4, 6, 8. So if you take n is even, minus 1 power 2, I am discussing about the bracket because this decides the total value bracket. So minus 1 power 2, it will become plus 1 and minus 1, so totally an will become 0. So if n is even, an is 0, that is a clarity. And similarly, if n is odd, if you take n value odd, like 1, 3, 5, 7, 1, 3, 5, 7 and so on, what happens? Minus 1 power 1, minus 1, minus 1, minus 1, minus 2. The bracket is minus 2. And minus 1 power 3 also minus 1, minus 1, minus 1, minus 2. So finally, if n is odd, the an value is becoming minus 2a by pi square n square. So this is about an. I think clear. Now bn, let's go to bn in the same way. So formula for bn, what is bn formula? 2 by t integral 0 to t x of t sin n omega naught t sin n omega naught t dt. So let's have capital T, take capital T is 2 pi and integral here 0 to 2 pi, but 0 to pi x of t is available, which is a t by pi sin n omega naught is 1, so sin nt dt, because t is 2 pi, omega naught equal to 2 pi by t, that is why omega naught is 1, already we discussed. Let's do this integration and 2 get cancelled here. So remaining bn is equal to a by pi square, again uv formula, u is the t, v is the sin nt, this is u and this is v. So u integral sin minus cos nt by n, this is by n, and minus u dash t derivative is 1, integral v minus cos, again integration of cos sin. So here you get sin plus sin nt by n square. So limits are 0 to pi. Substitute upper and lower limits. So if you go for upper limit pi, so a by pi square, upper limit is pi minus cos n pi divided by n plus sin n pi divided by n square. This is the upper limit value minus lower limit. So lower limit is 0, so here 0 into cos 0 is 0, sin 0 also 0, so lower limit value is 0. Okay, let's do this simplification. Sin n pi already we know it is 0, sin n pi is 0, right? Now the remaining bn is equal minus a pi by pi square n cos n pi, right? Here pi get cancelled, so minus a by pi n cos n pi. Cos n pi value minus 1 power n, so we can write that minus a by pi n minus 1 power n. So this is the bn. So finally we write the answer x of t. A naught, what is the a naught value we have? We go to previous page. What is a naught? a by 4, a naught is a by 4. So take that a by 4 plus summation 1 to infinite n is 1 to infinite an. So what is the value of an? What is the value of an? Minus 2a by pi square n square. That to be n is odd. Minus 2a by pi square n square minus 2a by pi square n square. This is an cos n omega naught t. Omega naught is 1. So this an only for odd values of n, right? Odd n. That clarity I am giving here. Plus bn. So we know bn minus a by pi n minus 1 power n sine omega naught n. What is sine omega naught nt? Omega naught is 1, so sine nt. Okay, so summation is for both. This is the answer. Right? In the similar way, we go to another problem. Let's do this problem. Find trigonometric Fourier series for the given periodic signal or periodic waveform. So this is a half wave rectifier output waveform. This time we are taking half wave rectifier output waveform. This is a half wave rectifier output waveform. Similarly, left side also, and so on. So this is 0, this is pi, 2 pi, 3 pi, x-axis is t, minus pi, minus 2 pi. The amplitude of the signal is a. Amplitude is how much? A. The given signal is x of t. So this is half wave rectifier output. Rectifier output waveform or output. So find trigonometric Fourier series. TFS, trigonometric Fourier series. So how to do? Very simple and easy. So first we need to identify the time period. So 0 to, where to where? 0 to pi or 0 to 2 pi? 0 to 2 pi. One complete cycle. Right? From 2 pi, the same signal is repeating. So time period is 2 pi, fundamental time period. Then fundamental frequency is 2 pi by t. Right? So 2 pi by t is equal to 1. 2 pi by 2 pi 1. And we have to write x of t expression 0 to 2 pi. So how to write x of t expression? Here pi by 2. So if t is equal to 0, we have signal 0. If t is pi by 2, we have a. How much? A. If t is equal to pi, 0. So this is satisfying sine function peak amplitude a. So a sine t. A sine t. Where to where? 0 to pi. What about pi to 2 pi? In Fourier series, trigonometric or exponential Fourier series, we have to define x of t over one time period. For one time period, we need to write x of t. So 0 to pi completed. What about pi to 2 pi? X of t is 0. It is pi to 2 pi. X of t is 0. This is the clarity about x of t. After x of t, we take Fourier series definition. Trigonometric Fourier series definition, we know x of t is equal to a naught plus summation 1 to infinite an cos n omega naught t plus bn sin n omega naught t. Right? This is the trigonometric Fourier series. Do a naught. So a naught is equal to average value or DC value of x of t. 1 by t 0 to t x of t dt. So take x of t here, a sin t, and this x of t is available only 0 to pi. So limits also, integral limits also 0 to pi. Time period is 2 pi. but here 0 to pi, pi to 2 pi it is 0. That is why 0 to pi x of t is available. A sin t dt. So do this integration. A sin t. A you can write outside 2 pi sin integration minus cos t, and here limits 0 to pi. So substitute limits minus a by 2 pi cos pi minus cos 0. So this value is cos pi value minus 1, cos 0 1, minus 2. Again outside we have minus, so it will become 2a by 2 pi. 2 to get cancelled. A by pi. This is the a naught value. What is the a naught value? Average value a by pi. Let's go to an. So an formula 2 by t integral 0 to t x of t into cos n omega naught t dt. So let's go to t is 2 pi and integral limits 0 to pi. Actually 2 pi, pi to 2 pi, x of t is not available. So 0 to pi, a sin t, x of t is a sin t into cos n omega naught. What is omega naught value? 1. Right? Omega naught is 1. That is why n t dt. So here 2 get cancelled. Now an is equal to a by pi. It is like sin a cos b. Sin a cos b. What is the trigonometric formula? Sin a cos b. Sin a cos b is equal to sin a plus b plus sin a minus b by 2. Sorry, here plus sin a minus b by 2. Just a trigonometric formula by 2. Otherwise 2 sin a cos b is equal to sin a plus b plus sin a minus b. So in the same way we have, so take integral 0 to pi sin a plus b. Here a is the t, b is the nt, so t is common, so sin 1 plus nt plus sin a minus b sin 1 minus nt divided by 2. So I am writing outside dt. Integration same. So let's do the integration of sin 1 plus n, sin 1 minus n. So an is equal to a by 2 pi. Here sin integration minus cos 1 plus n t divided by 1 plus n. So again here minus cos 1 minus nt divided by 1 minus n. Limits are 0 to pi. So we can take minus common. Both the terms are having minus. That minus is common. So minus a by 2 pi. Substituting limits, upper and lower limits. Upper limit is pi. So cos 1 plus n pi by 1 plus n. And lower limit is, sorry, only upper limit again, 1 minus n pi by 1 minus n. This is the upper limit substitution, minus lower limit. Already minus we have taken out, so here plus. Now lower limit is 0, so you get cos 0, which is 1 by 1 plus n, plus here also cos 0, 1 by 1 minus n. This is the lower limit substitution. Now values, what is the cos n 1 plus n pi? 1 plus n pi. How much? The value of cos 1 plus n pi. See, cos n pi, we know cos n pi is minus 1 power n. So here we have cos 1 plus n pi. So it will become minus 1 power 1 plus n. Right? Same, in the place of n, 1 plus n, so power 1 plus n minus 1 power. So take n value odd, 1, 3, 5, 7 and so on. So minus 1 power 1 plus 1, minus 1 power 1 plus 3 plus 1. So if we take n value odd, we are getting cos 1 plus n pi is plus 1. So here I am writing it is plus 1 for n is equal to odd. So same, n is even, for example 2, 4, 6, 2, it will become minus 1 if n is even. That is the clarity about 1 plus n pi. Similarly 1 minus n pi, 1 minus n pi. So see here 1 minus n pi, 1 minus n pi, cos 1 minus n pi. So it will be written as minus 1 power 1 minus n. That's all. Cos n pi is minus 1 power n. So cos 1 minus n pi is minus 1 power 1 minus n. Take even and odd. First think odd. Minus 1 power 1, 1 minus 1, 0. Minus 1 power 0 is 1. And 3, minus 1 power 1 minus 3, minus 1 power minus 2, which is plus 1. Right? 3. If you take 5, again plus 1. So this value is becoming plus 1 if n is odd. N is odd. And if you take n is even, 2, 4, 6, 8. So minus 1 power 1 minus 2, minus 1 power minus 1, which is the minus 1. 4, minus 1 power 1 minus 4, minus 1 power minus 3, again minus 1. So if you take n is even, the value is becoming minus 1. So this is the clarity about this 1 minus n pi, 1 plus n pi cos. So we are going to take the same clarity. So minus a by 2 pi, minus a by 2 pi. Okay. Discuss n is odd. If n is odd, what happens? Here 1 by 1 plus n plus 1 by 1 minus n minus of 1 by n, 1 plus n plus 1 by 1 minus n. So cancel. So answer is 0. This is the case when n is, what is the n? Odd. So an is equal to 0, n is equal to odd. Next, even. If you take the even, what happens? If you take even, next, if you take n is even, so an is equal to minus a by 2 pi, minus a by 2 pi, minus 1 by 1 plus n, because n is even. Again minus 1 by 1 minus n, right? And minus 1 by 1 plus n plus 1 by 1 minus n. So here minus 1 by 1 plus n, minus 1 by 1 plus n. It will become minus 2 by 1 plus n, again minus 2 by 1 minus n. So simplifying, minus 2 we can take common, so 2a by 2 pi, here LCM 1 minus n plus 1 plus n divided by 1 plus n into 1 minus n square, a square minus b square. So here plus n minus n cancel, and 2 get cancelled, 1 plus 1, 2a by pi into 1 minus n square. This is a an when n is even. Right? Next, similarly, we go for bn. So what is bn formula? Bn is equal to 2 by t integral 0 to t x of t sine n omega naught t dt. So let's have substitution 2 by 2 pi here 0 to pi x of t is a sine t, right? Sine n omega naught is 1, so nt dt. So here 2 get cancelled. It is like trigonometric formula sine a sine b, sine a sine b. So what is the trigonometric formula sine a sine b? A by pi integral 0 to pi cos a minus b, so cos 1 minus nt, right? Here a is the t, b is the nt, so t common 1 minus n, minus cos a plus b 1 plus nt divided by 2, so that I am writing outside dt. Now we can do integration easily. So a by 2 pi, what is the cos integration? Sine 1 minus nt minus again cos integration sine 1 plus nt here divided by 1 minus n, here divided by 1 plus n. So limits are 0 to pi. So by substituting upper limit 1 minus n pi, 1 minus sine 1 minus n pi, sine 1 plus n pi. Actually we know that, what we know, sine n pi is equal to 0. So sine 1 minus n pi is also 0. Sine 1 plus n pi is also 0. Right? Any integer pi, sine 1 pi, sine 2 pi, sine 3 pi, 1 minus n pi, 1 plus n pi, zeros. So we are going to take these values here. Then a by 2 pi, 0 by 1 minus n, here also 0 by 1 plus n. So totally bn is 0. But if you take n value 1, n is equal to 1, sine 0, here also sine 0 is 0, 1 minus n here, 1 minus 1 also 0. So if you take n is 1, bn we are going to see, because 0 by 0 we are getting, which is undefined. Let's do that small thing. If n is equal to 1, what is bn? So actually bn formula 2 by t integral 0 to t x of t sine n omega naught t dt. So take n value 1, so 2 by 2 pi integral 0 to pi a sine t sine, here n value 1, so omega naught also 1, sine t dt. So here 2 get cancelled, a by pi sine theta, sine square theta, right? So I am writing once again, a by pi integral 0 to pi sine t into sine t, sine square t dt. So sine square theta or sine square we can write as 1 minus cos 2 theta by 2. So integral 0 to pi 1 minus cos 2t by 2 dt. So let's do this integral or integration. So a by 2 pi integration of 1 is t minus cos sine 2t by 2. Substitute limits 0 to pi. So upper limit is pi, so a by 2 pi, so upper limit pi minus sine n pi, sorry, sine 2 pi divided by 2 minus lower limit is 0, so 0, sine 0, 0. So this sine 2 pi is also 0 because sine n pi is 0. So the remaining is a b 1 because n is equal to 1. So a by 2 because pi cancel. So this is the value of p1 only for n equal to 1. Okay, bn is 0 actually we have, but n equal to 1 we are getting situation 0 by 0 which is undefined. That is why we are doing actual value of b1 same by using bn formula. Okay, right? So this is the way of doing Fourier series problems, right? Thank you students. Thank you for watching. We will meet again. Thank you.